Welcome, ladies and gentlemen, and we're looking at lesson 2.5, solve problems using right triangles. How exciting is that? Okay, so there is some new terminology that we need to learn. You have to learn what an angle of elevation is, and you have to know what an angle of depression is. An angle of elevation, let's think about the word for a minute. Elevation. What's another word that sounds like elevation or kind of when I say elevation, I think of elevator. Elevator. Going up, right? Elevator going. That's a song by The Clash, by the way. And if any of your parents are old enough to know that song, that's a great song. So, elevator going up. And then we have angle of depression. Now, that's not a sad angle. That's not an angle that mopes around and listens to very sad music. This is an angle of down, of rotating down. Angle of elevation is rotating up. Angle of depression, like a depression in the ground, like a hole in the ground, it's an angle going down. So, angle of elevation, by definition, we're going to say the angle between the horizontal and the line of sight up to an object. And the angle of depression is going to be the horizontal and the line of sight down to an object. So look what I got here. I got a picture. I got a boat. I got a plane. It depends where I am, which angle of elevation or depression I'm talking about. So please, let's think about someone on the boat at the moment. If I have a horizontal, I can draw horizontals anywhere I want along this line. Here's a horizontal. 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 Look at all those horizontals. I just drew a whole bunch of horizontals. The neat thing about mathematics and this concept of horizontal is I can put it anywhere I want. It doesn't change what's happening. Now there's two horizontals that are particularly interesting to me right now. Those two horizontals is the horizontals from a person looking up at the plane. So this one, that horizontal is interesting to me. And the horizontal of someone from the plane looking down at the boat. That horizontal is interesting to me. So this one's interesting. And this one is interesting. The others are really just not that interesting at the moment. They're there, they're around, I could put a gazillion of them there, but they're just not that interesting. Now, when I want to talk about an angle of elevation from the boat, then what I'm talking about is some guy sitting on the boat and he sees the plane and he has to, now think of yourself on the boat. Someone says, there used to be a great movie, a show on TV. It was called Fantasy Island. If any of your parents remember that, oh my gosh, they're old like me. So Fantasy Island used to have a guy that used to say, the plane, boss, the plane. And he would be pointing up to the plane like this. Everybody, put your arms up like this. The plane, boss. You're not doing it. The plane, boss, the plane. And what he was doing was making an angle of elevation up to the plane. And there's the angle of elevation. Angle of elevation. Right there. That one. Put the hand up and he went, the plane, boss, the plane. And he pointed to the plane. It had to go up. That's angle of elevation from the horizontal. Now the guy in the plane, or the gal, doesn't matter, or gender in specific, it doesn't matter. The pilot of the plane is in the plane. And they have to look down at the boat. Okay? They have to look down. So the angle of depression is here. That is the angle of depression. So an angle of elevation goes up from the horizontal, and an angle of depression comes down from the horizontal. Now I'm going to freak you really out. This angle measurement right here, and this angle measurement right here are equal. Why? Do you remember the Z pattern that you learned in grade 9? So this is actually equal to each other, and we're going to use that information, but they're different angles, aren't they? So this is that Z pattern we used to talk about. These two angles are in fact equal, but they have different names, and they are different angles. Wow, that was fun. Let's do example 1. Hey, that rhymes. Did you hear that? That was fun. Let's do example 1. That's great. That's awesome. Okay, so the height of the tree is 6.2 meters tall. From a point 8.5 meters from the base of a tree, determine the angle of elevation up to the top of the tree to the nearest degree. Hey, that rhymes too. To the top of the tree to the nearest degree. This is awesome. Okay, so this tree is really a very nice diagram, but in all honesty, it really should just be a straight line. Okay? Yeah, that's a nice tree and all, but it's going to complicate things. Let's just make it a straight line. So here is my tree. And then from a place 8.5 meters from the base of the tree. Well, don't put up your hand and say, where's the base of the tree? Well, it ain't the top, so it's going to be down here. So it's going to be 8.5 meters from the base of the tree, that being the base. I think that's fairly obvious. And the tree is 6.2 meters tall. And as we've said before, we're going to assume a 90-degree angle here. Now, in reality, trees don't always grow at a 90-degree angle, but you know, and for mathematical purposes, we're going to assume that they do. So it's going to be going up at 90. So the height of the tree is 6.2 from a point 8.5 meters from the base of the term. Determine the angle of elevation. So I'm a little tiny ant. I'm on the ground, and I'm looking way up to the top of the tree. And the angle of elevation is right here. From the horizontal, which in this case is the ground, up to what I have to look at to see the top of the tree. This, ladies and gentlemen, I'm going to call theta. I have someone in the room who doesn't like theta. He wants to call it x all the time. That's fine. We'll let him do that. I've probably got another kid in the room that wants to call it angle A all the time. That's fine. I don't care what you do, but we need to call it something. All right, so now, let's see what I've got. There's my 90. That's going to be my hypotenuse. Does anybody care about the hypotenuse? No. This is my 90. This is my angle. This is going to be opposite. This is going to be adjacent. Okay, so I want to calculate an angle. It has to use adjacent and opposite. What's the trig ratio? Lucas? For opposite and adjacent. That's 10. Dead on. So, tan of theta. I use theta. Fernando in the class is going to use x. Someone else might use a. I really don't care. Is going to equal opposite 6.2 over 8.5. Now let me be very, very clear here. If you get this confused, you put the 8.5 over the 6.2, you're wrong. You're just not kind of wrong. You're wrong. And everything else will be wrong. So don't do that. Okay, so notice I'm after an angle. Angle. You want to find an angle. That means that we need to call Captain Inverse. And so we call Captain Inverse. So angle theta is going to equal tan inverse 6.2 divided by 8.5. I don't like to put the decimal in there. I like my calculator to do the work. So 6.2 divided by 8.5 equals, look at that. Would you have wanted to write all that out? Because you can't round it. You can't just do part of it. You need all of it. Okay? Second function, tan. And I get angle theta equals approximately 36 degrees. So in other words, I have to look. I have to raise my eyes about 36 degrees up to see that tree. Now, pause the video there for a moment, and I'll be right back with you. All right, now that you're back, I want to make something very, very clear. do you see this tree and this angle? What would happen if I was tall? What would happen if I had a height of maybe 1.5 meters? What if this was me and I'm 1.5 meters tall? That's my head. Nice head, right? That's me. I'll give myself some arms and some legs. So I'm not at the very ground looking up at the tree, right? I'm standing tall. Now where's my horizontal? This was the horizontal from the ground. This is the horizontal from my eyes. Do we agree that that's a horizontal as well? And I could draw it there. And using that horizontal, I could look up to the top of the tree. Now this creates a very different triangle, but do you see the triangle I'm now looking at? I'm now looking at this triangle. Okay? I'm now looking at this triangle. This angle here that I have to look up from this horizontal to this line is going to be similar to this angle that I have to look up, isn't it? Okay? So if you do it from your eyesight, you just have to remember that these are going to be changing a little bit. But the horizontal doesn't change that much, does it? I'm still going up from the horizontal to that angle. Because what's happening is you've got this angle and we've got this angle, and they're going to be similar to each other. We'll talk more about that as we go on. Example 2. The angle of depression from a plane to an airport is 25 degrees. Now, if I try to draw that right now, I'm going to get confused. So I'm going to hold off to that. I'm going to hold on to that idea for a minute. Angle of depression, plane to airport, 25 degrees. The altitude. What's another word for altitude? What word can we substitute altitude? Yeah, height. That's right. So the height of the plane is 10,000 feet. Now, when we talk about the height of the plane, don't we generally mean straight up and down? Right? So it's the vertical distance to the plane. So our height is 10,000 feet. That make sense to everyone? Now I can put in this angle of depression to an airport. Let's put the airport over here. I'll use A for airport. I'll use P for plane. And I'll use G for ground. How's that work for everyone? Is that good? I'm going to create the triangle now. Now, can I be very, very serious? Don't be drawing me pictures of planes. Just do little dots, and that's good enough. Okay? So there's my plane, there's my ground, there's my airport. And the angle of depression from my plane to my airport. Now, that requires a little bit of work. I need a horizontal. Now, this horizontal is the same as that horizontal, just placed differently. This horizontal is for the plane. And the angle of depression is given from the horizontal down. So this is actually 25 degrees. And when you're doing these questions, you have to show me that. You have to show me the angle of depression and where it goes. Now, the truth of the matter is, this horizontal and this horizontal make that cute little Z pattern from grade 9. And that cute little Z pattern says that this angle of 25 is equal to this angle of 25. But let me be clear. You have to show me the angle of depression before you put it inside the triangle. If I don't see it outside the triangle, I take off marks. Okay? If you don't want to put the 25 in here, we could also get an angle in here, knowing that this is 90. So this should be 90 minus 25, which will be 65 degrees for that part right there. So in this triangle, this is a little different than the other ones we've been doing. I found both interior angles other than the 90. So I'm going to have options, right? Options are fun. Okay, so what the heck does the question want? Determine the direct diagonal distance from the plane to the airport. So we want to know what is the length of PA. Now, you could have called it X, you could have called it D, you could call it whatever you want, but if I call it PA, I think everybody understands what I'm talking about. So now, we got to do some work. We know our hypotenuse. And we're given two angles. Like I said, you now have options. Which angle do you want to work with? And it's completely up to you. You can work with the 25, you can work with the 65, but you cannot work with the 90. Which one? Lucas? 25. So this 25 is the one we work with. That makes this opposite, and that makes this hypotenuse. That makes this adjacent. Nobody cares about the adjacent. They haven't given us any information for the adjacent, and we don't want anything. Poor adjacent. It's like your little brother. You ignore him. Nobody cares. So sad. All right. Opposite has 10,000. Hypotenuse is what we want to find out. The angle that we're working with is 25. What uses opposite and hypotenuse? Winston. What uses hypotenuse and opposite? Good man. So sine of 25 equals 10,000 over PA. Oh no! Dudes and dudettes, look what's happened. The unknown's in the bottom. It's in the bottom. I tell you. What's the bottom called? What's another name for the bottom? Denominator. So it's in the denominator. So this makes this a little bit trickier. Not a lot trickier. Make a fraction equals a fraction. Always the first step. Cross multiply. PA times sine of 25 equals 1 times 10,000. Is PA isolated? Is this all by itself? Nuh-uh. Nuh-uh. What is the sine 25 doing to the PA? Multiplying. What's the opposite of multiplying? So if I divide by sine of 25, I'm going to be left with PA, right? But to keep the equality, what I do to one side, I have to do to the other side. Grab your calculator. 10,000 divided by 25 sine equals, and we know that the distance from the airplane to the airport on the diagonal is given by 23,662.0. Oh, it said round to the nearest foot, so no 0.0. Feet. Yay! We're amazing! I'm going to pause the video there and we'll be back in a minute.